Hello and welcome to my digital presentation on the technology transitions of lighting. I will be talking about how Arizona State University is lighting its campus, as well as the way that how I think ASU should be lighting its campus. Now, ASU being such a large institution, you would probably assume that they have systems in place to use the resources in the most efficient manner. However, when it comes to lighting, I just don't see it. Now, this picture is interesting to me because I took this on the weekend, and here you see the lights are on and the building was locked and nobody was in it. So that's just one point to show I'm not sure if ASU is utilizing its resources to the fullest. So the question is, how should ASU illuminate campus? I'm going to start from the oldest and come to the newest techniques of lighting. Here's the oldest. That's the sun, which is still the greatest source of light. Now, can the sun be used as a source to illuminate its campus? Well, actually it can. Seeing as how we're at ASU and the sun shines a lot, the sun could be used in a technique called daylighting. And daylighting is simply just what it sounds. It's the sun coming into the building during the day and lighting its classroom from like that. Although daylighting is a new developing technique that is evolving fast, we are seeing many techniques to improve buildings' daylighting, such as switching out to smart windows and using adjustable shades and various other things. So now here's the next. This is a candle. This is the next transition of light that we're using way back when. And then we moved, Thomas Edison in 1890 moved us to the light bulb. We were able to not just use fire to make light, but we used electricity to make light. And then even more advanced became the compact fluorescent, which you could see in this spiral looking, or it also comes in the form of a tube, which is this here. So that is the compact fluorescent. Now here, this is inside of a flashlight. This is actually an LED bulb. So that tiny little thing right there, that is what an LED looks like. Okay, so the current method. What is the current method that ASU uses to illuminate its campus? Through my observations, ASU is pretty much using CFLs. Now this is because we're looking indoors. They use high intensity discharges outdoors, which actually have a high intensity discharge laying around. Right here. Bam. This is basically a glorified incandescent, and this produces a lot of light as well as a lot of heat, which is why it's not suitable for indoors. So the only two options we're really going to be looking at is CFLs or LEDs. However, for the better option, I'm going to throw in one more twist, which is using that old thing I like to call daylighting. And so that is utilizing the sun to the fullest and using LEDs as supplemental lighting for days when the sun isn't shining as much. So to get through the equations, we're going to have to make some basic assumptions. And these assumptions are about the building size, how many bulbs are in the building. We start with, we're just going to do 1,000 light bulbs to make it easy. Then how much light do we need from each bulb? And that is the intensity of light is measured in lumens. And we're going to ask for 2,800 lumens per bulb. That's a pretty good amount of light. Now, how much energy does it take for a CFL to produce that much light? Well, here you see it consumes 55 watts of energy. produce 2800 lumens of light, whereas an LED only consumes 28. So this is why LEDs cost $35 a bulb, whereas CFLs only cost about $4 a bulb, because they're not as efficient. So after we get that, we have to see how long are these bulbs going to be on, and that's going to be for 50,000 hours of use is going to be for a decade, which I calculated to be approximately 13.7 hours of use a day. So that seems pretty reasonable. Now, how much is this energy going to cost us? Here I'm writing 8 cents per kilowatt hour, which is a little bit lower than you might use in your home, 10-11 cents, but since ASU is such a large purchaser of energy, perhaps they get a discount. Here you see the equations I'll be using to get to what light will cost us less. This is the reoccurring payment, this is the sum of total payments, and then sum the reoccurring payment added to the initial payment, and you have the net present value, which in our case is going to be a negative number. So we're going to look at it in terms of net present cost, which you just need to put a negative in front of your net present value to get a net present cost. So for our first option, we look at the control, which is what we're doing now. So it's going to cost us $0 on an initial investment, but it's going to cost us $240,000 every decade over the course of 5 decades. It's going to cost us approximately, rounded down, $4 million. Well, let's compare that to if we were to retrofit a building with daylighting and switch all the bulbs to LEDs. This is going to cost us initially quite a bit more, as you see, $250,000. That's assuming it would cost $215,000 to retrofit some more windows into the building, as well as swapping them out, and that is going to divide our hours of use in half. So not only are we consuming less energy, we're using it for less hours, and we're replacing it less often. We're only going to need 1,000 replacement bulbs every other decade, which is why you see that jump every other decade. So plug that into the net present value equation, and we get a net present cost of approximately $1.4 million. So that's almost $3 million in savings, roughly 3 times cheaper to operate over the next 50 years. Now, I used a discount rate of 15%, so you could see here if I varied it, that a higher discount rate, which I chose relatively high, actually favors the CFL more, because that comes down a lot steeper. Now, I'm going to finish up by saying here's the economic reasons. As you can see, this wide gap is how much money you would be saving, and it would be in the millions. That's for that. Now that's just for the economics, okay? If we're considering sustainability, such as the durability of the bulb, LEDs are way more durable. If you're considering things like your health, well, it's very dangerous to have 5 milligrams of mercury in each bulb, which is exactly how much a CFL has. And if that's to break, just spontaneously explode, which you could say, oh, that'll never happen. Well, actually, CFLs have been known to spontaneously explode at extremely low or extremely high temperatures. Now, the last but not least, the feasibility of the LED light compared to the CFL, the feasibility of using it with technology is way greater, because LEDs could be attached to motion sensors where they turn on instantly. CFLs do not, and LEDs won't be affected by a frequent on-off cycle. The lifespan will be the same. A CFL's lifespan would be shortened. So, in conclusion, use the sun, use the LED. Thank you much for listening.